be solving this problem called edit distance. So the edit distance between two strings is the minimum number of operations required to transform one string into the other. The allowed operations are add one character to the string, remove one character from the string, replace one character in the string. For example, the edit distance between love and movie is 2 because you can first replace L with M and then add I. Our task is to calculate the edit distance between two strings, and our strings here will be of length up to 5000, and this is an indicator about the complexity here, so we can have a complexity up to n squared. So let's just keep that in mind, and the sample example here is what was described here, and the answer here is 2. So let's go to the drawing board and see why this example actually gives 2. So as we saw in the example, the minimum number of moves we need to perform to make love look like movie is 2. We will change this L to M and then we will add an I here. And to get started with solving this problem, we can notice something, and this is just a coincidence, but the last letter of both words is the same, and this raises the question of whether or not we will change this E. So since both words are ending with an E, it means that this problem is similar to finding the minimum of love without E and movie without E as well. So if we knew the answer to this, it would be exactly the same as the answer to this, because then we will just add E to both words since they end in the same letter. And what this indicates is that this problem can be broken down into prefixes of this word. So if we knew, for example, how many moves we would require to make love without E identical to some prefix of movie, then that might give us some insight into how to extend this prefix longer until it becomes the whole word. So in order to understand this better, let's go ahead and see the number of moves required to make every prefix of love equal to every prefix of movie. So let's get started. Let's suppose that our first prefix is just the letter L, and let's see how many moves we would require to make it equal to just the prefix M. So since these two letters are different, we would require one move, namely changing this L to an M. So that's why we would require one move to make L identical to M. Moving on, now let's suppose we have this prefix. So how many moves we would require to make L identical to MO? We would need to transform this L to M and then add another letter. So we would require 2 moves, and so on. So for the next prefix we would require 3 moves, the next one 4, and finally 5 to make L identical to movie. Now let's move on to the next prefix, which is LO. And in order to make LO identical to M, we would actually need to perform 2 moves, namely erasing one of these letters and changing the other one to M. So we would need 2 moves here. Moving on, now we have the prefix MO. Notice here that these 2 prefixes end in the same letter, so we will just need to change this L to M, performing just 1 move. So in order to make LO the same as MO, we will just need 1 move. Now moving on to the next prefix, MOV, and here we would actually need to change this L to M and insert another V at the end, and that's why we would need 2 moves. Next, for movie, we would actually need 3 moves because we will need to insert another I at the end. And finally, for the whole word, we would require 4 moves. Now let's move on to the next prefix. We have a 3-letter prefix, namely love, And in order to make it identical to m, we will actually need 3 moves, because we will have to erase 2 letters and change one to m. So we would require 3 moves here. And next to the next prefix mo, we notice here that we have a letter in common, so we can just erase this v and change this l to m, and that would require 2 moves. Now next prefix is mov, and we notice here that we have 2 identical letters here, o and v, so we only require 1 move to change this l to m, so we will just require 1 move here. And the next prefix is movi, and here we would require 2 moves, and the second one is to insert an I at the end. And finally, for the whole word, we would require 3 moves. And now for the whole prefix or the whole word, in order to make it identical to m, we would require 4 moves, because we will need to erase 3 letters and change one to m, so 4 here. And to make it identical to mo, we would actually require 3 moves, namely erasing 2 letters and changing this one to m. And for the next prefix, we have mov, and for that we will only require 2 moves, and that is erasing this letter and changing this l to m. So we would require 2 moves here. And for the next prefix, we have movi, and in order to make it identical to this prefix, we would require 2 moves, namely changing this e to I and this l to m. So 2 moves here as well. And finally, in order to make this identical to the whole word, we would actually require 2 moves, and that is to change this l to m, and another move to insert here. So that's it. We found the minimum number of moves required to make every prefix of love identical to every prefix of movie. Now let's go ahead and make sense of the results we got. So the first thing to observe is to see what happens at the intersection of 2 identical letters, like here, or here, or here. As we said before, since movie and love end in the same letter, the minimum number of moves required to make movie identical to love would just be equal to the number of moves required to make this prefix equal to this prefix. And that's why this 2 is identical to the value that is 1 up and to the left from it. And the same goes for this one, and the same goes for this one. So if we have an intersection of 2 identical letters, the number of moves required at that position will be just equal to the number of moves required at the position up and to the left from it. So that's the first remark. And now let's try to make more sense of the values we have here. Let's focus on this value, for example. This tells us that the minimum number of moves to make low equal to mauve is equal to 2. And the question now is, can we deduce this from previous results we've got? So when we were looking for this value, these were the values we knew. We knew all these values. So can we actually deduce this value from all what preceded? And the answer is yes. So for example, what does this one represent? This one represents the minimum number of moves to make law equal to mu. So we know that min of law and mu is equal to 1. So with this and one actual extra move, we can add a v here. And what does this 3 mean? This tells us that the minimum to make L equal to mauve is actually equal to 3. And finally, what does this 2 mean? This 2 tells us that the minimum to make L equal to MO is actually equal to 2. So given all these informations, can we actually find the minimum value of make it law equal to move? So from this first result, we know that we can get more in one move. And then in order to make it equal to v, we will actually insert a v here, and that would require one extra move. So this tells us that we can get to this result in one move. Next, from this second result, we know that we would require 3 moves to make L identical to MOV. But since we don't have L by itself, but instead we have LO, in order to get to this state, we will have to erase this O first. Then we will have the identical situation like this one, and then we would require 3 moves to go there, and plus this extra move. This tells us that we would require 1 extra move to go there, for a total of 4, and this was for a total of 2. And finally, we know that we would require 2 moves to make L identical to Mo, and then since we have LO, we would require 1 extra move to erase this O, and then we will just add a V at the end. So that would require 1 extra move as well, and this would require 3 moves at the end. And since we are looking for the minimum, we can just pick the minimum of these 3 values, which is gonna be 2. So as you can see here, for all values that are not in the intersection of 2 matching letters, all these values are just the minimum of these 3 values plus 1. So 2 is the minimum of these 3 values, which is 1 plus 1 gives us 2. This 4, for example, is the minimum of these 3 values plus 1, which is 3 plus 1 gives us 4. This 2, for example, is the minimum of these 3 values plus 1, and that's actually 1 plus 1 gives us 2. So in this case, we would require 1 move to make love identical to MOV, and at the end, since I and E are different, we would just change this E to an I, and that would require 1 extra move. So every position can be obtained from the position on top of it, the position to its left, and the position immediately up and to the left from it. And we could obtain this value by just taking the minimum of these 3 values and adding 1. But what about these values at the boundary? I don't know what value is on top of this, and I don't know what value is to the left of this one. So how can I extend this idea to the values at the boundary? And in order to do that, we will do the following, but just before, we will just note here what we just found. So else, if we don't have this condition, then the min of I and j is equal to the following. So as we said, the minimum up to position I and j is the minimum up to position I, j minus 1 plus 1, or the minimum up to position I minus 1, j plus 1, or the minimum at position I minus 1, j minus 1 plus 1. And we will just take the minimum of all these. And now let's go back to solving the problem of finding adjacent values for the values that are on the boundary. And we could do that very easily by doing the following. I can go ahead and select all these values, for example, and I will just make extra space here, and then I will select all these values and make some extra space here, and consider one additional prefix, and that is the empty prefix. And here as well, I will consider the empty prefix, and I will do this one more time. So how many moves do I require to make the empty string identical to the empty string? And the answer is just 0. Now for m, I would need to add another letter to the empty string to make it equal to m, so this will be 1. and this will be 2, 3, 4, and 5. And the same goes for this column. So to make L identical to the empty string, I will have to erase it. So that would require one move, and for the prefix LO, I would require erasing 2 letters. So this is 2, and this is 3, and this is 4. And what we can notice here is that these values will be identical for all strings. They only depend on the length of the word and have nothing to do with the characters. So I can go ahead and set them right at the beginning, and we can see here that the pattern we described here still works even for the values that were at the boundary before. So this one would be equal to the minimum of 1 plus 1, 1 plus 1, and 0 plus 1. And the answer here will be 1 because 0 plus 1, and so on. So basically we can store our answer in a 2D array, let's call it DP for example, and set it to be of length max, representing the 5000 we saw earlier. And then we will initialize this first row and this first column as we saw, and then we will just loop through all the characters of both strings, starting from the first character of the first string and looping through all the characters of the second string, and so on. And at the end our answer will be at the last position here. So let's go ahead and check out our code. So this is our program. We'll start by defining our max value as we said. I will define it as a const int and call it max, and I will set it to 5005. Then I will declare my array of ints, and ints should be fine here because we would at most have values up to 5000, so no worries about overflow. And I am making my DP two-dimensional as we saw. Then I will declare my two strings. I will call them str and ptr. I will read them. Then I will do the initialization we described earlier. So this is for initializing the first row, and I will loop through all values up to the length of my target string plus 1, and I will set all these values equal to the actual position. And I will do the same for the first column. Then I will have two nested for loops that will go from 1 to the length of the string plus 1, and the second variable will go from 1 to the length of the target string plus 1. Then I will initialize the minimum number of moves with infinity that I defined here to be a billion, and I need to do that because I am minimizing this value, and if I don't, the value that it was initialized with was 0, and if I just leave it like that and do min afterwards, it will just keep at 0 because 0 is a min of itself and any other positive value. So that's why I set it to a very large value. Then I will just do what we described here, like the two conditions, and I will just mix them in just one condition. So I can embed this into here by just having, so I have this min of I-1, j-1, and I also have it here. But the only difference is that I add a plus 1 here, and I don't want to add it when the two characters are equal. So in order to account for that, I can just replace this one with a Boolean expression. And a Boolean expression is just a statement that returns 1 if it is true and 0 otherwise. So I can replace this plus 1 with si is different from pj, I mean. So if si is different from pj, then this expression is correct and it will be replaced with a 1. So I'll get the min I-1, j-1 plus 1. Otherwise, if they are equal, then this will be replaced with a 0, and I will get that initial case I had here. So that's it. So the min at position ij is equal to the min of the minimum moves up to I-1, j-1 plus the Boolean expression str of I minus 1, and here I have I minus 1 because as we saw these are shifted by 1 to account for the empty string. So see here, when we were at position 1 here, we were actually just dealing with the first character of the string. That's why we have to subtract 1. So that's why I'm checking the string at position I minus 1 and j minus 1. And I will add 1 if they are different and 0 otherwise, and I will min these 3 values. And at the end I will just print my answer, which will be located at the end of my starting string and my target string. So that's pretty much it. Let's go ahead and submit. So that worked. Thank you for watching. See you in the next video. Bye bye.